All right, let's look at the definition of a box plot. So a box plot is a visual representation of the 5-number summary. And in the last section, we learned that the 5-number summary is the minimum value of a data set, the maximum value of a data set, as well as the first quartile, third quartile, and the median of that data set. Box plots provide a good graphical image of the concentration of the data. Box plots are also called box and whisker plots or box whisker plots. Box plots are typically drawn over or under number lines to give them context and scale for the data they represent. So down below, I've got an example figure of a box plot. So this is the number line that you want to make sure that you draw on there with values in the number line. And you want to give the number line a title with units. Okay, so we have some context for the box plot that we're going to draw or display or present. And what we've got here is the box plot itself. And you can see the 5-number summary up above. And so, we've got the minimum, first quartile, median, third quartile, and maximum. And so the minimum value is represented by this short vertical line right over the minimum value in this case, which was 34. Then you've got the first quartile, which is represented also by a vertical line. And that vertical line is positioned on the value 38, which was the calculated first quartile. The median is represented by another vertical line, and that vertical line is positioned above the value 46, because 46 was the calculated median for that data set. Third quartile is again represented by a vertical line above the value 50, and 50 was the calculated third quartile for that data set. And finally, we've got the maximum value, and that's represented by a short vertical line, and that is over the value 54, which was the maximum value for this data set that this box plot represents. And now that you've got those 5 vertical lines drawn or in place for each value in the 5-number summary, you create a box by connecting the vertical lines between the first quartile and the third quartile. So top and bottom. And that makes your box of a box plot. And then between the third quartile and the max, you draw just a single line connecting those two. And then between the minimum and the first quartile, you draw a single line connecting them. And that's basically all a box plot is. The box itself, which is between the first quartile and the third quartile, remember that the first quartile is the 25th percentile, and the third quartile is the 75th percentile. So the width of this box actually represents the middle 50% of the data. So up here, where I define a box plot providing a good graphical image of the concentration of the data is kind of where is the middle 50%. Is the middle 50%, centered between the minimum and maximum, or is the middle 50%, closer to the minimum, or is it closer to the maximum? Okay, in this example, the middle 50% looks like it's slightly shifted towards the minimum a little bit, but not too much. But sometimes where you see this middle 50%, shifted way over to the minimum or shifted way over to the maximum, says something about the data, and we'll get into that later. And it also when you look at this box, you can say that, the middle 50% of the data is between the values 38 and 50. All right, so that's also useful to know. I myself have used box plots in my professional career. So here's an example where I was conducting experiments, making a rare earth oxide ceramic, and I was making it in part for its transparency, how well you could see through it. And so I had done all of these experiments, trying to compare how transparent each sample was. And I was trying to figure out why some were more transparent than others. And so what I was doing is I was characterizing the size of the impurities that I could see in the sample. And so I would take all these impurities and measure them, and I would have box plots of those impurities. And so you'll see that these box plots, so that I could put them side by side, I oriented them vertically. But down here is where you have the minimum value, and up top is where you have the maximum value. This is the maximum value for that one. Here is the maximum value for that one, and so on. And here you could see that for this second box plot right here, okay, the middle 50% is actually closer to the minimum value. That seemed to be a common behavior for a lot of these. So that translates to these being right skewed, these distributions being right skewed. But you haven't learned that yet. We'll get to it. One other thing you'll notice about these box plots is, in addition to the 5-number summary, maximum, third quartile, median, first quartile, and minimum, some software packages allow you to put in the average. So that's what this little box is in here, is that's the average of the data. And the average of the data is different than the median of the data. Those are two different measures of center, but we'll get into that shortly. Okay, so that concludes the definition of a box plot.